In this video, we're going to review our physics lesson of war. So in this lesson, we looked at projectiles being launched at different angles. So we discussed in class that since once again, the x and y variables are perpendicular and independent of each other, we must calculate them separately, and thus any resultant vectors that we have, we must break them down into their x and y components first. Also, much like our Thelma and Louise lesson, which was horizontal projections off a cliff, we discovered as a class that the one variable that can be transferred between the x and y components is time. So let's take a look at our question here as a review. So here it says, flying fish can launch themselves into the air with speeds of 70 kilometers an hour. If their projectile angle is 34 degrees, how high and how far did the fish jump? Okay? First, I'm going to make a quick diagram. So here I have my fish, and he is jumping at an angle of 34 degrees. And that's 70 kilometers an hour. But we like to work here in meters per second. So I'm going to go 70.0 kilometers per hour, and I'm going to divide that by 3.6 to get meters per second. Now that's going to end up giving me a total of 19.4 meters per second. Okay? So here I have 19.4 meters per second is my resultant velocity. Now, we need to figure out what is my y and what is my x velocity, because that's always step one. Break them down to your x and y components. We have a resultant, we're going to break them down to x and y. So for my y, I'm just going to go 19.4 sine 34 degrees. And that's going to give me a total of 10.9 meters per second. Okay, now let's look at my Vx. That's going to be 19.4 meters per second cosine of 34 degrees. And that's going to give me a total of 16.1 meters per second. Okay, so here I have my Vy is 19.4, oops, sorry, not 19, is 10.9 meters per second. And my Vx is equal to 16.1 meters per second. Okay, now that we have those broken down, we could look at our next part. So in our next part, we're going to want to figure out how high it went. So that's our first question. So in that case, we're looking at my y's. Okay, so let's look at my y components. So in this case, we're trying to figure out what is my distance. Okay, we know my initial velocity in my y is equal to 10.9 meters per second. We know my acceleration is going to be gravity. So for the maximum height, if you remember, if something shoots up to a maximum height, it's going to stop temporarily in the y before it comes back down. So we want, for our maximum height, we know my Vf in this case of a y is equal to 0 meters per second. Okay? So if we look at this, we have these four variables. Which equation am I going to use? In this case, I'm going to use Vf squared, my final velocity squared, is equal to my initial velocity squared plus 2 times my acceleration times my distance. Now in this case here, we know my y is equal to 0. So we really don't need to look at that. Now I'm going to put it so we have negative 2 times acceleration times distance is equal to my initial velocity squared in the y. So now we have to isolate for d because we're trying to find the distance. So I'm going to divide this by negative 2 and my acceleration. So overall we end up getting my distance is equal to my initial velocity squared divided by negative 2 times my acceleration. And we have 10.9 meters per second squared, meters per second, divided by, and we have negative times 2 multiplied by negative 9.81 meters per second squared. Okay? Now when I calculate that, that's all squared. Okay? When I calculate that, I'm going to end up getting a total of 6.06 meters. So we know my distance in the y, or his maximum height, is 6.06 meters. Now, let's look at the second part of the question. It says, how far did the fish jump? Now I want to figure out how far the fish jumped. That is in my x. But in order for looking at that, we're going to first have to find out my time. And with my y vectors and my y components, we could find my time, and then we could apply that to the x. So let's now look at my time. So we want to figure out here what my time is. Okay? So looking at time, we have these 4 components. So we have velocity, initial, acceleration, final velocity, and time. So for this one, I'm going to be using this equation from our formula sheet. Final velocity is equal to initial velocity plus acceleration multiplied by time. All right? Now my final velocity there is 0, so we could kind of ignore that. And we want to isolate for time. So I'm going to have my negative initial velocity subtracted from both sides is equal to, then we have to divide both sides by a. All over a is equal to my time. Okay? So we're going to plug in our numbers here. So I get negative 10.9 meters per second divided by negative 9.81 meters per second squared. This altogether is going to give me 1.1 seconds. Okay? So, we know my time for half of it, just to reach the maximum, is 1.1 seconds. So my total time, we have to multiply it by 2, is going to be 2.2 seconds. Is going to be my total time. And this was only for half. Alright? So now we have that. Now we can look at my x. We know my total time for the whole flight of the fish. We can start looking at my x. So we're looking at my x components now. Now when we're looking at my x components, there's nothing affecting the velocity in the x. We always ignore air resistance in this class, so there's nothing affecting the velocity in the x. It's neither accelerating or decelerating in its flight. So in this case here, we want to find my distance of x is equal to my velocity of x multiplied by just how long it's in the air, multiplied by my time. So we end up going here, we're going to end up having 16.1 meters per second multiplied by 2.2 seconds, it's in the air. And that's going to end up giving me a total of 35.4 meters. So this flying fish ended up going 6.06, so like 6 meters high, and 35.4 meters far in its jump. So once again, let's review. First thing I must do is break it down into its x and y, first thing I must do is break it down into its x and y components. So I have to take my resultant and make sure I have them in my x and my y. After that, I'm going to look at each one separately. Most of the time, we're going to look at my y to find the time. Sometimes we could look at my x component to find the time. As remember, time is the only thing transferable. Here we wanted to find how high it went. So I used my y first to figure out what is my distance. Then I used my y components to figure out the time it was in the air. So I found out how high it went, or the time it took to get to its max, and then I times it by 2, because for something to go up, it's going to take just as long for it to come back down. Then I use that time and transfer that over to my x, because remember, time is the only thing transferable, to calculate my distance in my x, for my x components.